Calculate final drafts and trim in different loading conditions. Trim change problem change draft at 1 and change of trim and draft change of trim and draft problem solving.
Good day everyone, good day ma'am. This is the Cadet Ben Casidamulo and we are the group 2. And today we are going to report the topic calculate final draft and trim in different loading condition.
Good day ma'am, this is the group 2 and I am the Cadet Adrian Alan Batarna. We are reporting the moment to change trim. If the shape in figure 9 is figure 4.9 is trimmed by moving a weight W with its initial position to a new position H forward, the trimming moment will be WH. This will cause the center of gravity of the shape to move from G to G and the shape will trim caused by B to move to B. The trim is difference in draft forward and aft. The change in trim angle can be taken as the change in that difference divided by the longitudinal distance between the points at which the draft are measured. The moment to change trim MCT 1 meter is convenient figure to quote to show how easy a shape is to trim. It should be noted that the wheels most authorized use a meter as the unit change. Some use the MCT by 1 cm. It is recommended therefore that the full title is given, example MCT 1 meter. The value of MCT is very useful in calculating draft at which a shape will float for a given condition of a loading. Suppose it has been ascertained that the weight of shape is W and the center of the gravity is X forward of a midship, and that at that weight with a waterline parallel to the design waterline, it will float and draft T with the center of buoyancy Y forward of a midship. There will be a moment W times the quantity of Y, taking it away from waterline parallel to change to the design one. The shape trim about the center of flotation by an amount equal to the moment divided by the MCT for the waterplane. The draft at any point along the length can be found by a simple ratios. Additional stiffening in the pounding region. If the minimum design draft forward in a ballast or part loaded condition is less than 4.5% of ship length and the bottom structure for 30% of the ship length forward in sea-going ship, exceeding 65 meter length is to be additional strengthened for pounding. Where the double bottom is transversely framed, solid plate floor are fitted at every frame space in the pounding region. Intercoastal side girders are fitted at a maximum spacing of 3 times the floor spacing, and half height intercoastal side girder are provided midway between the full height side girder. If the double bottom is longitudinally framed in the pounding region where the minimum design draft forward by may be less than 4% of the ship length. Solid plate floor are fitted at the alternate frame space and intercoastal side girder fitted at the maximum spacing of 3 times the transverse floor spacing. Where the maximum design draft forward may be more than 4% but less than 4.5% of the ship length. Solid plate floor may be fitted at every third frame space and intercoastal side girder may be a maximum spacing of 4 times the transverse floor spacing. A longitudinal are the stiffening the bottom shall longitudinally. It should be noted that the fewer side girder need be provided than where the bottom is transversely framed to resist distortion of the bottom with the slamming forces experienced. Where the ballast draft forward is less than 1% of the ship length, the additional strengthening of the pounding region is given special consideration. Greater slamming force, example pounding, are experienced with when the ship is the lighter ballast condition and is long and slender by reason of increased submersion of the bow in heavy weather with impact also on the flare.
True mean draft. True mean draft effect of hog and sag on draft. When a ship is neither hog nor sag, the draft amidship is equal to the mean of the draft forward and aft. In figure 38.1, the vessel is shown in hard outline floating without being hog or sag. The draft forward is F. The draft aft is A. And the draft amidship, Kx, is equal to the average of the draft forward and aft. Now let the vessel be sagged as shown in figure 38.1 by the broken outline. The draft amidship is now Q1x, which is equal to the mean of the drafts forward and aft Kx plus the sag KQ1. The amount of hog or sag must therefore be taken into account in calculations involving the draft amidships. The depth of the vessel amidships from the keel to the decline QY or Q1Y1 is constant, being equal to the draft amidship plus freeboard. So, this means that a ship's true mean draft is measured at the center of flotation and may not be equal to the average of the draft forward and aft. When a ship is trimmed by the stem and the center of flotation is up of amidships, the correction is to be added to the mean of the draft forward and aft. This also tells the general rule for the application of the correction to the draft amidship in order to find true mean draft. When the center of flotation is in the same direction from amidship as the maximum draft, the correction is to be added to the mean of draft. When the center of flotation is in the opposite direction from amidship to the maximum draft, the correction is to be subtracted. That's all. Thank you.
By having it aft, so that essentially there's no change here. So the instructions for parallel sinkage is the difference between the initial mean draft and the final mean draft. Step 2 would normally be that we have to calculate MTI and TPI, but they're already given to us, so we actually can skip. Okay, so that is going to be TPI times parallel sinkage. So we have to calculate this parallel sinkage. We slide it either aft or forward, all right, to determine the distance to put it, right? Okay. So what's that mean draft? 2106. Sink it 6 inches. Once we've sunk it 6 inches, then we'll slide the weight back. So we are going to, by doing that, we're going to increase the forward draft by 6 inches. But wait a minute. If we increase it by 6 inches, we're no longer at 21. If we load the weight back aft, we can change the trim by 6 inches. All right. And that will get us back to 21 feet. So normally we'd have to go to the deadweight scale, but since we're... So there are those givens. Now we're going to go to step 3. What's the weight? Well, weight's going to equal TPI times parallel sinkage. Well, we have TPI. So now we'll go on to step 4. This is where we have to calculate the trim change, or the total change in trim. And, well, 21, 22, our final trim we want to be 12 inches. So, our trim forward is 12 inches. Okay. Probably could have figured that out just by looking up here, but that's... Add enough weight to this vessel to sink it 6 inches. Once we've sunk it 6 inches, then we'll slide the weight back. So we are going to, by doing that, we're going to increase the forward draft by 6 inches. But wait a minute. So now we'll go on to step 4. This is where we have to calculate the trim change, or the total change in trim. Our final trim we want to be 12 inches. So, our trim forward 12 inches. Okay. Probably could have figured that not just by looking up here, but that's the sort of the math for how to do that. This is gonna, all right, so anyway, so trim change equals trimming moment divided by MTI. All right, well, again, we can break trimming moment down into two variables. Trim change equals weight times distance times 1035 divided by 288 and 43. And we have to put it aft so that we can bring the drag, we can increase the drag aft. If we put a weight of 288 tons at a center of gravity 43 feet aft of it down at 43 feet, the forward draft would remain the same, and all of the draft changes would happen at the stern drafts. Okay? There is a spot like this for up forward, where if we had the problem a long way, there actually is a shortcut that we can use. So here's how the shortcut works. There's a formula for it. The distance that you'll load, okay, to keep the draft the same at one end will be 2 times the MTI divided by the TPI. So if you do that, that's 2 times 1035 divided by 48. We were given 1035 and 48. The distance is 43. You can see that. It's the same distance. Well, if we want to keep the trim, if we want to keep the draft.
Hello everyone, I am going to explain on how to calculate the change of trim. So number one is the length of your vessel is 480 feet forward draft, 18 feet and 7 inches and 22 feet and 3 inches after. So the TPR is 46, MCTI is 1,130 feet tons. CF is at amidship. A weight of 100 tons is loaded 180 feet forward from amidship. Solve change of trim. So solution. The formula of this problem is change of trim equals weight times distance over MTI. So the weight is 100 tons times 180 feet, and that is the distance over 1,130 feet tons, and equals to 15.93 inches by the head. The second one is find the final mean draft and trim. So a vessel floating in a salt water is a draft CF. So port forward is 61 feet and 8 inches, and the port after is 65 feet and 12 inches. So the STBD forward is 70 feet and 7 inches, and the STBD after is 72 feet and 16 inches. So what is the trim and the final mean draft? So this is the solution. We are going to put the after here 65 feet and 12 inches, and the STBD after is 72 feet and 16 inches, and we are going to add that one, and the answer is 137 feet and 28 inches, as well as the forward is 61 feet and 8 inches, and the STBD is 70 feet and 7 inches. So we are going to add that as well. It will become 131 feet and 15 inches. So the 131 we're going to automatically add 1, so it will become 132, and the 15 is, this is more than 1 foot, so we are going to subtract it. So 15 minus 12 is equals to 3. There is a 3 there, and the after 137 feet and 28 inches. So we are going to add 2, it will become 139. And how do we get 4? So 28 minus 12 is equals to 16. So this is more than 1 foot. So 16 minus 12 is equals to 4. So there is a 4 there. So we will divide it into 2. 132 divided by 2 is 66. And 3 divided by 2 is equals to 1. So we're not going to put a decimal there. And herein after is 28. We will add 28 and 4. It is equals to 22, and 139 divided into 2 is 69.5. Then we're not going to put the decimal there. So the mean draft final. So mean draft after is 69 feet and 32 inches. And the mean draft forward is 66 feet and 1 inches. So we are going to subtract it. So the answer is 3 feet and 31 inches by the stern. So that is the trim. That's already the answer. Thank you.